Good day, Doctor and everyone. My name is Satishkumar Palaniappan from Section 4 and Group 2. So today I will present our paid teaching note for Case 33 in SATK 3564 Process Control and Instrumentation. The purpose of this video is to introduce the basic feedback controller mode, explain how feedback control system works, and discuss controller training for stable and efficient control process. Basic control mode for the feedback controller is in the feedback control system. Those proportional control, integral control, and derivative control. So each control mode have a different function and they are often combined from a PID controller for better process performance. So proportional control produce an output that directly proportional to an error between the set point and the measured process value. When the error increases, the controller output also increase proportionally. Therefore, the proportional control provide a fast response to change in the process. So proportional control equation. The controller output depend on the controller gain, also the KC and the error signal. Increasing the control gain makes the controller response more quickly, but if the gain is too high, the system becomes unstable. So the transfer function for the proportional control is simple equal to the control gain. However, proportional control has one major disadvantage, which is it can't completely eliminate the steady state error, also called as offset, after a set point change or disturbance. The integral control eliminates the steady state error by continuously accumulating the error over time. This makes the process output evenly reach the desired set point. However, excessive integral action can produce oscillation and reset point out. So the proportional and integral action are commonly combined to form the PID controller. So derivative control predicts the future behavior of the error by considering its rate change. It improves the system stability, reduce overshoot, and provide a smooth response when a proportional, integral, and derivative action are combined. They form a PID controller, which is widely used in the industry process. So this slide, we can see that standard feedback control system, the controller compares the set point which the measure output to calculate the error. Based on the error, the controller adjusts the manipulated variable so that this process output reach the desired value. Diagram. So for example, Y represents the control variable, U is manipulated, and D is disturbance, and E is signal error. So understanding those inputs help us to analyze the control system more efficiently. So this slide explains how the system responds when only the set point change while disturbance remain constant. And desired closed loop equation describes how controller adjusts the process output to follow the new set point accurately. Unlike the previous slide, this case assumes that the set point remains constant while disturbance enter the process. The controller works to reject the disturbance to maintain the desired output in ensuring the stable operation. And here, the stability is one of the most important requirements in the process control because it predict response and evenly reach the desired operating condition without the oscillation. And this slide introduces the rod stability gradation. It's a mathematical method used to determine whether the control system is stable by examining the characteristic equation without solving all the roots. And here you can see the first order plus time delay and the second order plus time delay. So now tuning is the process to selecting suitable controller parameter. So the main objective we can see achieve the fast response, minimize overshooting, reduce stability error, and introduce the stable system. And here we can see that the proportional, integral, and derivatives parameters explanation is also introduced the common tuning method, including the Ziegler's Excel method on the right side, and error and automatic tuning, which help the good controller performance. In conclusion, understanding of basic mode and feedback control system, stability analysis, and controller using tuning is initial for the design efficient and reliable industry process control system. So that's all for me. Thank you.